So in this video, I'm going to show how you can create a digital thermometer using a Raspberry Pi. So you'll obviously need the Raspberry Pi itself. Mine's a version 3, Model B. A breakout board. 3 female to male jumper wires, as well as 2 male to male jumper wires. A 4.7 k ohm resistor, and the main component is the thermometer. So the model here is a DS18B20. There are slightly different variants available online in terms of thermometer, but this is the one that I'm using. In terms of the schematics, it's important to note the colors of the probe. In my example, I've got a yellow, red, green. So yellow here represents ground, our red represents positive, and our green represents data. Depending on the supplier that you get the cable from, the colors may vary, so you just need to check in terms of which one's your ground, your positive, and your data. So we're going to connect the probe onto the breakout board. In terms of the wires coming out of the Raspberry Pi itself, we're going to be looking at the 3.3 volt, the ground, and the GPIO pin 4 for the data. We use our jumper cables to link up our breadboard as well as the Pi, and the resistor will be sitting between our positive and our data. So I'll start off by connecting the cables to the Pi itself. You'll notice that I've used specifically red, yellow, and green jumper wires to match the colors that's on the probe, just to make it easier, but obviously it's not required. So our red being our positive, we're going to connect to our 3.3 volt. Our yellow cable will connect to our ground. And our green cable being our data will connect to position 4. Now, I'll leave the connecting the thermometer last just because I haven't crimped male leads to the cable, so it's not exactly in terms of like a firm fit. So we'll connect up all the jumper cables and then we'll leave this one till last. So our red is our positive, so it will connect to the positive rail on the board. Yellow is our ground, so that will connect to the negative rail on the board. And green will just line up with wherever our thermometer data lead is, so we'll connect that up to position 15 for now. And we need to jump our positive and negative to align up with our thermometer. So we'll connect our red cable, which is our positive, to the next position. So you can see they're kind of side by side. And our ground cable from our negative rail to the next position. So you can see we've got our yellow, red, green. Now the resistor is going to connect the red, between the red and the green, our positive and our data. So that's positions 15 and 14. Okay. And lastly, the thermometer. So if we align the colors, yellow, red, green, it will be positions 15, 14, and 13. That's it. So I'll just zoom in. So now that we have all the circuitry wired up in terms of our digital thermometer and the Raspberry Pi, you should be good to go now to plug in the micro USB cable into the Pi, power it up, and we'll go through what we need to do at an OS level. So we'll start off by SSHing into the Pi. And we need to add support for the thermometer at boot. So to do this, you need to type in sudo nano boot, and we're going to update the config.txt file. So if you go right to the bottom, we'll type in dt overlay equals w1 for one wire dash GPIO. Okay, Control X, Y, enter. And then we'll reboot the Pi. So once the Pi's back, we can SSH back in. Now at this point, you can skip straight to the Python code that allows us to read the temperature, but there's a couple of commands that we can run via SSH just to check that it's working. So if we enable the probes, so sudo mode probe, GPIO, sudo mod probe, w1 therm, we'll change into the devices directory. So if you do an ls after you've changed into sysbus w1 devices, and you see a folder kind of with a similar syntax to this one, we've got 28 dash. That's actually the unique device ID of the thermometer. So unique IDs allow you to have potentially multiple thermometers hooked up to the same Raspberry Pi. So if we change into the 28 directory and then do cat w1 slave, this is the file that we'll read to get the temperature. So every time we hit this particular file, we should get so the temperature is still the change. So I might hold the thermometer just to warm it up. And you can see there it's gone up to 25 degrees. So that's the way it's measured in Celsius. The first two, it's 25.000 in terms of like kind of a float for Celsius degrees. Okay, so in terms of the Python code, go back to home. So this is the code that I have. We're basically importing OS and time. We enable the probes, we specified the directory in terms of where the W1 slave file is. We read the lines in the file, and then we extract the temperature and just do a bit of string manipulation before we print it back out to screen. So if I exit this, we just run the command. You can see it's spitting the temperature out to the console.